Okay, so in Unit 7.3, we are solving exponential equations using logs, and we're also solving logarithmic equations using exponents. There were several people who had questions on checkpoint number 2, which is focused specifically on solving logarithmic equations. So I'm going to go through a couple of those problems and just kind of explain this step-by-step process. So I'm going to start with number 3, where we have 4 times log base 5 of x minus 1 equals 8. And we know from previous problems that the first thing we want to do here is cancel out that 4 in the very front. So since the 4 is being multiplied, I'm just going to divide by 4 on both sides. So that's going to give me log base 5 of x minus 1 equals 2, because 8 divided by 4 is 2. Okay, so right here, the next thing we want to get rid of is the log. Well, you have to do the opposite, and we know that the opposite of an exponent is a log, so then the opposite of a log is an exponent. So here, we're going to convert the entire equation to an exponent. So when you convert, you always start with that base, so this is going to be 5 to the second power equals x minus 1, right? You always drop that base straight down, and then everything else rolls over. So 5 to the second power equals x minus 1. From here, it's pretty easy going. 5 to the second power, 5 to the second power, we know is 25. So this is just 25 equals x minus 1. And if you want to get x by itself, you're going to have to move that 1 to the other side. So all we need to do here is add 1 to both sides, and we've got our final answer. X equals 26. Bring this down, and the next one we're going to take a look at is number 5. So number 5 on checkpoint number 2 says log base 4 of 1 over 6x minus 2 equals 0. And notice that there's not a number out in the front of this one. It's just that logarithm. So to get rid of a log, you change it to an exponent. So we're going to start with the base here. I'm going to bring that down. It's going to be 4 to the 0 power equals 1 over 6x minus 2. When you switch from a log to an exponent, you always bring that base straight down, and then everything else rolls over to the opposite side. So 4 to the 0 power equals 1 over 6x minus 2. Now we're going to get our calculator out and do some math here. I'm going to start by computing 4 to the 0th power. 4 to the 0th power is 1. So I have 1 equals 1 over 6x minus 2. And we just have to keep going through this thing and getting x by itself. So I'm looking over here where the x is, and I know I need to get rid of that minus 2. So to move it to the other side, I'm going to add 2 on both sides. That gives me 3 equals 1 over 6x. Now, this is usually the step where people get stuck, is how do you get rid of a fraction? Well, the opposite of 1 over 6 is 6 over 1. So we're actually going to multiply both sides by 6 over 1. And the reason why this works is if you have 6 over 6, it cancels out. And so you're left with just 1x on this side. And then on the opposite side, you have 3 times 6 over 1. And realize here that 6 over 1, 6 divided by 1 is just 6. 3 times 6 is 18. So our final answer, x equals 18. All right, we're going to try one more from checkpoint 2. The last one we're going to look at is number 7. Number 7, we've got 1/3 times the natural log of 100x minus 3 equals 3. So we know in this problem we need to get rid of the number out in the very front first. So again, we're dealing with a fraction. The opposite of 1 over 3 is 3 over 1. Those 3's, the 3 on top, the 3 on bottom, that'll cancel out, so we're left with just one natural log. So I can just write natural log of 100x minus 3. And then over here it's just 3 times 3 over 1. Well, 3 over 1 is just 3, so 3 times 3 is 9. Okay? All right, so we get rid of the number out in the very front first. Now we need to get rid of the log. To get rid of a log, you change it to an exponent. The problem here is we don't know what the base is. Well, remember that natural log is the same thing as log with a base of e. So you can really think of this problem as log base e of 100x minus 3 equals 9. So now, whenever you get ready to change it into an exponent, you would start with a base of e. So this would be e to the 9th power equals 100x minus 3. Okay, you always drop that base straight down. Everything else rolls over to the opposite side. So I'm going to get my calculator out here. This is e, which you do second ln, and that'll do e to the 9th power, is a really, really big number. Let me see that. What was that number? 8103.08. 8103.08 equals 100x minus 3. And we just want to get x by itself here. So we are going to look over here and I see minus 3. We're going to have to add 3 to both sides. So that'll make this 8106.08 equals 100x. And then last, to get x by itself, we can just divide both sides by 100. So that's going to be 8106.08 divided by 100. Gives us 81.06 because we want 2 decimal places there. So 81.06. X equals 81.06. Yeah, I know we didn't cover all of the problems in checkpoint 2, but those are kind of the ones that I know people had asked about the most. So hopefully you'll be able to follow the steps on those 3 problems and apply it to the rest of the problems as well. Please let me know if you have any questions.